A determinant is defined only for square matrices. So, determinant of a square matrix is unique for a given square matrix. A is a square matrix from the set M and delta is the determinant value here. So, f of A is called the determinant of matrix A. For easier calculation, we shall expand the determinant along the row or column which contains maximum number of zeros. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am with Vidhyaashram School of Excellence, Mysuru. In today's session, we are taking the new chapter, Determinants. So, let's see what is the determinants. Now, here, determinants is defined only for a square matrix. Then what is this determinants? To every square matrix of order n, we know the order of a matrix of a square matrix is denoted by n. Either it may be a 2 cross 2 or it may be a 3 cross 3, 4 cross 4. Since the number of rows and number of columns are equal, we say it is a square matrix of order n. So, we can associate a number, it may be a real number or a complex number, and that number is called the determinants of a square matrix. So here it is denoted by determinant A in this form. This is not modulus A here, it is called as determinant of matrix A, or it is denoted by det A or by the symbol delta. So all these symbols are used to denote the determinant of A. Now let's see what is actual determinant. A determinant is defined only for square matrices. So, determinant of a square matrix is unique for a given square matrix. So, it is also defined as a function which associates every square matrix with a unique number. So, for every square matrix, a unique value can be defined and that value can be called as determinant of a given square matrix. Determinant as a function. So, when I take determinant as a function. So, when I take determinant as a function, that is we can call it in the form of f or delta, and let me consider m, where m is the set of square matrices and k is the set of numbers which is real and complex. In this chapter, we are going to study only the determinant value for real number. So, let us consider k is the set of unique real numbers. Now, if I define f from m to k, where m is a set of all square matrices and k is set of real numbers, then f of a is delta. So, this a is a square matrix from the set m and delta is the determinant value here. So, f of a is called the determinant of matrix A. So, this is how we can define the determinant for a given matrix. Now, let us study the determinant of a square matrix of order 1 cross 1, 2 cross 2 and 3 cross 3. So, the first one is determinant of a matrix of order 1. So, that means a matrix containing only one element, that is only one row, one column. So, that is A is equal to A. What is the determinant of this matrix then? It is always the value inside the given matrix. So, if A is a matrix containing an element A of order 1, then the determinant of A is A itself. For example, if A is a matrix containing element 3, then the determinant of A is 3 only. Next, determinant of matrix of order 2. Suppose I consider a matrix of 2 cross 2, that is I am containing A1, A2, B1, B2 as a unique square matrix, then the determinant or det A is defined as A1 into B2. That is, we know that this is a principal diagonal and this is a secondary diagonal element. So, it is the difference of the product of the diagonal elements, that is A1 into B2 minus A2 into B1. So, this is how we will define the 2 cross 2 order matrix. So, let's take few example here. So, we need to find the determinant of this matrix. So, let us write this in the determinant form 2, 4, minus 1, 2. Then how we are going to define this? So, we will multiply the principal diagonal elements, that is 2 2s are 4 minus the secondary diagonal minus 1 into 4, which is minus 4. So now minus of minus 4 becomes plus 4. 4 plus 4 is 8. So 8 is the number which is associated with the given 2 cross 2 matrix, which is the determinant of a given matrix. Next, evaluate x square minus x plus 1, x minus 1, x plus 1, x plus 1. So we are finding the determinant of the given matrix. Let's multiply these two elements. We have x square minus x plus 1 into x plus 1 minus x plus 1 into x minus 1. We have x plus 1 into x minus 1. Let's multiply x once. Then it becomes x cube minus x square plus x. Next it becomes x square minus x plus 1. This is x square minus 1 square. This is in the form of a plus b, a minus b, which can be written as a square minus b square, which becomes a square minus of minus becomes b square, which is 1. So you can clearly see here minus x square plus x square get cancels, plus x minus x get cancels. So we are left with x cube minus x square, 1 plus 1 is 2. So this is the value of the given determinant. Next, cos theta minus sin theta, cos theta. So here also let's multiply the principal diagonal element. Cos theta into cos theta is cos square theta minus secondary diagonal is sin theta is sin square. Since we have here minus, it becomes minus sin square theta, which becomes positive here. And we know that sin square theta plus cos square theta value is 1. Next, find the value of x for which 3x x1 equals 3241. So here we can use the concept of equality of matrices. Here they have given two determinants are equal. So we are supposed to find the value of x. Now here, let's calculate the determinant of this. We'll get 3 minus x square. And here we'll get 3 minus 8. So we can cancel 3 on both sides. Minus x square equals minus 8 implies x square is equal to 8. So x is equal to plus or minus root 8. So root 8 can be written in the form of 2 root 2. So the value is plus or minus 2 root 2. Next one, find the value of x for which x 2, 8, x 6, 2, 8, 6. So the two determinants are same here. We'll get x square minus 16 here. We'll get 36 minus 16. We can cancel 16. We'll get x square is equal to 36, or we can write x is equal to plus or minus 6. Do not write x is equal to 6 by comparing the first and the last elements here. So it is plus or minus 6. Next question, we have 2, 4, 5, 1, x 3, 2x 5. So 2 1s are 2 minus 5 4s are 20. Here we will get 5x minus 6x. So minus 18 is equal to minus x. So therefore x is equal to 18. Next one, if a is equal to 1, 2, 4, 2, then show that determinant of 2a equals 4 times determinant a. So first, let us find the matrix 2a. That means you are multiplying the scalar 2 to the given matrix. So let's multiply 2 to the given matrix. It becomes 2, 4, 8, 4. So this is the matrix. Now let us find the determinant of 2a. So what is determinant of this matrix? It is 2 4s are 8 minus 8 4s are 32, whose value is minus 24. Let's check for 4 times determinant a. So that is 4 times determinant a. We have 4 outside. Let's check for determinant of a. This matrix, 1 2s are 2 minus 4 2s are 8. So which becomes 4 into minus 6, whose value is minus 24. So we can clearly see here determinant of 2a is equal to 4 times determinant a. Next, let us study the determinant of order 3. So the determinant of order 3 has 6 ways of expansion since it contains 3 rows and 3 columns. So the process of expanding this determinant can be occur in 6 ways. But for the expansion, you can choose any one row or any one column which will give you the same value here. So now let us see the sign of the positions of element inside the determinant. So here every position of the determinant has their own symbol that is either positive or negative, and it is satisfied by -1 to the power I plus j here. Now, where I and jth position is called, we have studied in the matrix, that is I and j represents the position of an element inside the matrix. So now for 1, 1. So when I say an element A 1, 1, so let's check for -1 to the power 1 plus 1. So it is 1. So when I write the position of the first element, so here it is positive. So next, here -1 to the power, next one is A12, which is 1 plus 2, which becomes -1 whole cube, which is -1. So it is +1, -1. Similarly, +1, -1, +1, -1, +1, -1, +1. So this is how every number inside the matrix has its sign convention using the formula -1 to the power I plus j. So by writing this, we can assume the signs of a 3 cross 3 order matrix here. So thus we have plus, minus, plus for first row, minus, plus, minus for second row, plus, minus, plus for the third row. Now let us see the expansion of 3 cross 3 determinant in general form. So I have considered a matrix A containing A1, A2, A3, B1, B2, B3, C1, C2, C3, 3 rows and 3 columns. Let it be a square matrix. Then the determinant is given by determinant of the same values here. So how we are going to expand this? So here I am taking the first row. And for the first row, we should remember the sign convention, that is plus, minus, plus. How we are going to expand here? So let's see. Here we will take A1 and the sign is positive only. We will delete the row and column containing A1 and the remaining element should be written in the form of a determinant. So that is B2, B3, C2, C3. And we know to evaluate 2 cross 2 determinant. So that we will do it later. So an element containing the row and column has to be deleted and the remaining elements has to be written in the form of a determinant here. Next element I am taking minus A2 because the sign in the second position is minus. Now delete the row and column containing A2. Just write the remaining elements. What are the elements we have? B1, B3, C1, C3. So we will write this B1, B3, C1, C3. Next we will take plus A3 for the third one. And so delete the row and column containing A3. What are the remaining elements we have? That has to be written in the form of determinant. B1, B2, then C1, C2. So this is how we will expand. Now here what happens? A1 into, this is a determinant again, B2, C3 minus C2, B3. You know that you will multiply the principal diagonal minus secondary diagonal. The same way we can do for this also. So after simplifying this, we will get this in this form. That is A1, B2, C3 minus C2, B3 minus A2, B1, C3 minus C1, B3 plus A3, B1, C2 minus C1, B2. So this is how we are going to expand the given determinant. Now here expansion is along R1, that means row 1. We can also expand the given determinant using other rows also. Let us expand using any one column here. Let me take this one. What is the sign convention here? Plus, minus, plus. So you can see the sign convention. See, for the first column we have plus, minus, plus here. Let us expand this using A1, B1, C1. What happens now? First one, A1, delete the row and column containing A1. Then you will get B2, B3, C2, C3. Next you have minus B1. So minus B1, So delete the row, delete the column. So we have A2, A3, C2, C3. A2, A3, C2, C3. The last one is plus C1. So delete the row, delete the column. We are left with A2, A3, B2, B3. So this is how we are going to expand it. So this is an expansion along column 1, that is C1. So we can also take any other column or any other row for an expansion along with your sign convention. So all the expansion with any row or with any column will give you the same value. So delta will be same for any expansion along any row or any column. Now, when you're calculating the value of the determinant, the row or column containing zeros can be used for easier calculation. So, let's take an example here. Evaluate the determinant delta equals 1, 2, 4 minus 1, 3, 0, 4, 1, 0. Now, I'm considering first row. So, for first row, we have 1. Delete the row and column containing 1. We are left with 3, 0, 1, 0. So, 3 zeros are 0 minus 1 zeros are 0. Next, we have minus 2 because the sign convention is plus minus plus. Next, for 2, delete the column and row. We are left with minus 1, 0, 4, 0, whose determinant is minus 1 into 0, 0, minus 4 into 0 is 0. The last one is 4 we have. So, delete the column and row. We have minus 1 into 1, minus 1, minus 12. Clearly, you can see here 0 into 1, 0. 0 into minus 2, 0 here. Next, we are left with 4 into minus 13, whose value is minus 52 only. So, thus, you can take any column or any row for the expansion of determinant. Let's take one more example. Find the determinant of matrix A, 1, 1, minus 2, 2, 1, minus 3, 5, 4, minus 9. Here we don't have any zeros for easier calculation. Hence, you can use any row, any column for the expansion. I use the first row here. So, let's write 1. I'm using the first row. Remember the sign convention. For 1, delete the column and row. We have 1, minus 3, 4, minus 9. 1 into minus 9 is minus 9. Minus 4 3's is minus 12, which becomes plus 12. Minus 1, delete the column and row here. Minus 18, minus 15. The last one is plus, but we have minus 2 here. For minus 2, delete the column and row. We are left with 2, 1, 5, 4. 2 4's are 8. 5 1's are 5. So, now here we have 1 into 3. Minus 1. Minus 18, minus 15, which becomes minus 33. Next, we have minus 2 here. And here we have 3. So, we have 1 3's are 3. Minus into minus plus 33. 3 2's are 6. We have minus 6. So, 33 plus 3 is 36. Minus 6 is 30. So, therefore, the value of the determinant is 30. So, the next one, if A equals 1, 0, 1, 0, 1, 2, 0, 0, 4, then show that determinant of 3A is equal to 27 times of determinant A. So, let's find the matrix 3A here. What happens here? 3, 0, 3, 0, 3, 6, 0, 0, 12. Let's calculate the determinant of 3A. I am taking the first column because I have more number of zeros. You can also take second column if you want. Now, the sign convention is here plus minus plus. So, 3 into 12 3's are 36 minus 0 plus 0 is what the answer will get. So, 36 into 3 is 108. Let's check for 27 times the determinant A. So, therefore, 27 times of determinant A. For determinant A also I can use the first column and the sign convention is same. Let me write 27 outside here. So, let's take 1. So, for 1 it is 4 minus 0. Next we have minus 0 plus 0 there also. So here 27 into 4 we will get, which is also equal to 108. So clearly I can see that determinant of 3 times A is equal to 27 times of determinant A. So from the previous observations of evaluating the determinants, so we have a points to remember. For easier calculation, we shall expand the determinant along the row or column which contains maximum number of zeros. And here we have solved these kind of problem. We have taken determinant of 2A is 4 times determinant A. Determinant of 3A is 27 times determinant A. So in general, we can express determinant of A is equal to k to the power n of determinants B if your second determinant is the scalar multiple of your first matrix. So if A is a given matrix and B is the scalar multiple of matrix A, then we can express this in the general form of determinant of A equals k to the power n determinants B. So here the k value is the scalar and n is the order of the matrix here. So here we have taken 2 cross 2 matrix. So the k value is 2 and order of the matrix was 2 square. So the value is 4 here. And here the scalar value k is 3. Order of matrix we have taken is 3 for 3 cross 3 order. So therefore here the scalar value was 27. So thus in this session we have learned how to expand the determinant for 2 cross 2 and 3 cross 3 square matrices. I'll meet you in the next session. Until then, keep watching, keep learning, keep exploring. Thank you.